Hi guys, today we're going to learn about things called alkenes and alkynes. These are both kinds of organic compounds. Because they're organic, it means that we're going to have carbon and hydrogen in them. And when we're using these, the prefix that we use will tell us how many carbons our compound has. So we're going to review the number of carbons and those prefixes. Remember, our trick is Maria eats peanut butter. And that means that meth is the prefix for 1. Eth is 2. Prop means 3. But is 4, and the rest we know. 5 is pent, hex, hept, oct, non, and dec. So just to get those prefixes back in your head. When we're dealing with our C's and H's today, we need to remember about the bonds that they form. Carbon always forms 4 bonds and hydrogen always forms 1. So that means anytime that you have a carbon, it's going to have 4 bonds attached to it like that. Hydrogen will always have 1, and it doesn't matter what direction it goes, but it's the number of lines or bonds that are connected to each. So last time we learned about compounds called alkanes. And remember, alkanes only had single bonds in them. And to figure out the hydrogen number, we took our carbon number and we did a times 2 plus 2. But now we're going to learn about things that are different, and the words are very similar, so you're going to have to be careful of your spelling. Instead of alkanes, we are going to learn about things called alkenes. These are still hydrocarbons, so they still have carbon and hydrogen in them, but now there's going to be a double bond somewhere. So instead of a single line, we'll see this double bond like an equal sign. That will happen between the carbons, so you'll see something like this. That's what that will look like. Because of that double bond, that makes the compound unsaturated. The ending of the word that you'll see, the name, will be -ene because that matches alkene here. And in order to figure out the hydrogens there, it's a little bit different. You're just going to double the carbons. So do not times 2 plus 2, just double it. So let's do some practice here. Let's see if we can come up with some of these names with our prefixes. So the first one is going to be called methene. 2 carbons would be ethene. So keep going in your table. Propene, butene, pentene, hexene, heptene, octene, nonene, decene, and this is an extra box, it doesn't really matter. So you're going to have to be really careful of your spelling. Make sure that we can tell that this is heptene, but if you spell it wrong, it might look like heptane, and those are two very different things. So be careful of your spelling so that we can tell the difference, all right? Now let's see if we can come up with the formula for each one of these, okay? So the first thing is that methene does not exist. That is not a possibility. The reason why is if I want a double bond, it has to happen between 2 carbons. Meth means 1, which means I don't have 2 carbons to put the double bond between. So methene is never going to exist. We're going to work on the rest of them. Ethene, eth means I will have 2 carbons. And to figure out the hydrogens, I will just take this 2 and I will double it, so my hydrogens will be 4. Propene is going to be C3 because prop means 3, and my hydrogens will be just doubled as 6. So keep going down this table. Let's fill out some more. C4, H8, C5, H10, C6, H12, C7, H14, C8, H16, C9, H18, and decene will be C10, H20. The last thing that we're going to try to do is actually draw the structures of some of these, thinking about the fact that we're going to put 4 bonds on our carbons and we're going to put 1 bond on our hydrogen. So let's try with ethene first. I know I have to have 2 carbons. Just put them next to each other, but because of this ene ending, we're going to connect them with a double bond this time. Then you're just going to fill in so that every carbon has 4 bonds. So this one currently has 2, I'm going to do 3, 4. This one over here, same thing. It needs to have 4 bonds all together, and then you just put hydrogens on the outside. Now double check. We wanted to have 4 hydrogens, and I have 1, 2, 3, 4. That's how you know you did it right. Okay. If I do propene, put 3 carbons, but there has to be a double bond somewhere. So I can put the double bond there, or it honestly doesn't make a difference. You could also put the double bond over here, and either way is okay. Just go back and fill in 4 bonds on every carbon. So 1, 2, 3, 4. This carbon in the middle has 1, 2, 3, 4. 4 lines coming out of every carbon. Then just put hydrogens around on the other end of those bonds. And let's count. I have 1, 2, 3, 4, 5, 6 hydrogens. So we did it right. I want you to try butene and pentene and then compare structures with me. Okay, I'm going to put my 4 carbons here for butene. It does not matter where the double bond goes. I'm going to put it in the middle. It doesn't matter. We're going to put 4 bonds on every carbon. So there's 1, 2, 3, 4. Put hydrogens around the end. And there's your 8 hydrogens. Last one, we'll try pentene, so 5 carbons. Connect them all, but somewhere put a double bond. It doesn't matter, wherever you feel like it. Then just make sure that every carbon has 4 bonds all together. Put hydrogens on the other end. And there is pentene. We're not going to draw the rest of them because that gets way too long. If you want to, you can. But let's try a couple questions on this. If we had 20 carbons in an alkene, what we would do is we would use this formula. In this case, C would be 20, and we would double it. So H would be 40. If I had 30 carbons, then C NH2N, I would have C30, H60. Okay. Now, there's another kind of organic compound called alkyne. So we have ene and we have ine, and last unit you learned ane, so spelling is important. Here we're still a hydrocarbon, so we still have C's and H's, but now we're going to have a triple bond, so it's going to be 3 lines like that. That triple bond will make it unsaturated, so our carbons will be connected like this. The ending of those words will be ine with a Y-N-E, and the hydrogens are different here. You're going to double the carbons, but then you're going to subtract 2. So whatever your carbon number is, you're going to times 2 minus 2. So let's try some practice with that. Same thing, let's first just write the words. So we would have meth-ine, but again, this one does not exist. I don't have enough carbons to put a triple bond between, so that's not a thing. Let's try some of the rest of them, though. I could have ethine, propine, keep going. We have butine, pentine, hexine, heptine, octine, nonine, and decyne. This is again an extra box, it doesn't matter. Now let's try to use our times 2 minus 2 rule to figure out the formulas. So ethine is C2. I know it's 2 because of the F. Then if I want to do times 2 minus 2 for my hydrogens, it's just going to become C2H2. Propine is C3. The 3 comes from the prop. H's, if I times 2 minus 2, that is C3H4. So go through, can you figure out the rest of the formulas for these? I know it's but, which means 4 carbons. For the H's, I will times 2 minus 2. Pent means 5. Times 2 minus 2 is H8. C6, H10. C7, H12. C8, H14, C9, H16, and last one, decyne, is C10, H18. Okay, now let's see if for these couple where we have the space, let's draw what this would look like. So ethyne, I would draw 2 carbons, and because of the ine ending, I make it a triple bond. Then I just have to go back and give each carbon 4 bonds. They already have 3 apiece, so I just need 1 more. That's how I know that I have 2 hydrogens because of my formula. Propyne will have 3 carbons. Again, it doesn't matter where you put the triple bond. Just give every carbon 4 bonds all together. So this one in the middle is full. And then put your hydrogens around and count. We have 1, 2, 3, 4 hydrogens, so you did it right. Okay, I want you to try butyne and pentyne. So we have 4 carbons here. Put the triple bond anywhere, it doesn't make a difference. Then give every carbon 4 bonds. So I have 1, 2, 3, 4, 5, 6 hydrogens there. And last one we're going to try is pentyne. 5 carbons. I'm going to put the triple bond here, but it doesn't matter. Give every carbon 4 bonds. Put hydrogens on the ends. And there are your 8 hydrogens. All right, you're now an organic pro. Let's see if we can try these questions at the bottom. If I had 20 carbons in an alkyne, I would use this formula. So if my carbon is 20 times 2 minus 2 is 38 hydrogens. If I had 30 carbons and I used this little formula, I would do 30, and for my H's, I would times 2 minus 2. All right, see how you did. If you have any questions, come and ask.